Video 41. Problem number 1. Solve an plus 1 minus an is equal to 3n squared minus n. 3n squared minus n. And the n greater than or equal to 0 and a naught is equal to 3. Initial condition a naught equal to 3. Solution. First we have to consider the homogeneous part. Consider the homogeneous part. Homogeneous part an plus 1 minus an equal to 0. You know its auxiliary equation. So this is equation number 1. Let the trial solution be an is equal to r power n. Then 1 implies an plus 1 is r power n plus 1 minus rn an is rn is equal to 0. Rn is equal to 0. So this cancelling rn throughout, you will get r minus 1 is equal to 0. This gives r is equal to 1. Therefore, the value of an for the homogeneous part only is equal to a constant times r power n is 1 power n. So a into 1 power n. Now we have to find out this homogeneous part. Now we have to find out the particular solution. So we have to refer the tables. Now here 1 is a root. Okay. Here f of n is equal to 3n squared minus n, which we can term it as 1 power n into 3n squared minus n. 1 power n into 3n squared minus n. 3n squared minus 1. N squared minus n. You can treat it like this. That is, this is of the form c power n into f of n, where c is a root of the characteristic equation. This is a characteristic equation. Is a root of the characteristic equation. Root of the characteristic equation of multiplicity 1, because 1 is occurring only once, multiplicity 1, so f of n. So therefore what we can take, our an value is equal to an of p. We have to take an of the particular integral is equal to, what is the table gives? The table c power n, that is number 5. C is the root of character of multiplicity. This is n power t. T is 1 multiplicity into c power n into f of n is of degree 3. So therefore you will get degree 2 a naught plus a1n plus a2n squared. So this is our, which implies that is our an. An is equal to n into c power n into a naught plus a1n plus a2n squared. a2n squared. Now we have to substitute in the given equation. So now say this is 2. Using 2 in the given equation an plus 1 minus an is equal to 3n squared minus n, we get, what is an plus 1? An plus 1, wherever n occurs, put n plus 1. N plus 1, and by the way, the value of c is 1, we can have only n. C is 1. Therefore, if you multiply, you will get a naught n plus a1 n squared plus a2 n cubed. That we can take it as equation number 2. So an plus 1 is a naught into n plus 1 plus a1 into n plus 1 the whole squared plus a naught n plus a1 a2 into n plus 1 the whole cubed. This is the value of our an plus 1 minus an. What is minus an? An is a naught n plus a1 n plus a2 n squared is equal to, the right hand side is 3n squared minus n. So an, c value is 1. C is equal to 1. C is root 1. Now this implies a naught n plus a naught plus a1 into n squared plus 2n plus 1 is equal plus a2 into n plus 1 the whole cubed, n cubed plus 3n squared plus 3n plus 1 minus of a naught n minus a1 n minus a2 n squared, a naught n a1 n is equal to, so equal to 3n squared minus n, 3n squared minus n, a2 into n cubed. Okay, now here an value, what is an value? An value is a naught n plus a1 n squared, a1 n squared plus a2 n cubed. So this is minus a naught n minus a1 n squared plus n cubed, a2 n cubed. This plus a2 n cubed cancel with minus a2 n cubed, and then this a1 n squared cancel with minus a1 n squared, a naught n cancel with minus a naught n. What is the balance? Balance is a naught plus multiplying 2a1 into n, 2a1 into n plus a1 plus 3a2 n squared plus 3a2 n plus a2 is equal to 3n squared minus n. Now to get a naught, a1, a2, equating coefficient of n squared on both sides, 3a2 is equal to right side 3n squared. This gives a2 value is 1. a2 is equal to 1. a2 is 1. What is the next one? Equating coefficient of n on both sides, 2a1 n coefficient, then plus 3a2 n coefficient. Right hand side is minus 1. Substitute the value of a2 is 1, 3 into 1. So 2a1 plus 3 into 1 equal to minus 1. This implies 2a1 is equal to minus 4. So a1 is equal to minus 2. a1 is equal to minus 2. And equating constant on both sides, equating constant term on the left side is a naught plus a1 into 1, a1, a2 into 1, a2 is equal to right side, there is no constant, a naught, a1 value is minus 2, a2 value is plus 1 equal to 0, which implies a naught is equal to 1. So therefore an of p particular integral is from 2 a naught is equal to 1n, a1 is minus 2n squared, a2 is equal to, what is our a2 is equal to 1 plus n cubed. So n minus 2n squared plus n cubed, come on, by we are substituting in 2. Thus an is equal to anh, homogeneous part value plus particular part. What is our anh? We have taken a into 1 power n, that is a plus n minus 2n squared plus n cubed. So this is the value of an. We call it as equation number 3. Now still we have to find out what is the value of a. For that it is given a naught is equal to 3. That we will do it in the next video 42. In video 40 we will have to erase this recurrence relation with constant coefficient is.